Hey guys, welcome back. So today we're gonna be looking at center of mass. So good news is, uh, thanks to the reliever and Mrs. Shama, so I got the booklet now. So all right. So first on the booklet. So you guys would have been working on page 10, conservation of momentum, and also page 11, explosion and collision and impulse. So it has been quite a bit of work over here. So I think this week, probably on Friday or something, I'll just or even earlier, like I might just give you guys some time to work on some of these questions, okay? Or when I come back, like I'll give you guys some time. So let me know how you're getting on. If the questions are quite difficult or you don't have enough time to finish them, and let me know. I'll slow down a little bit for you guys. So but for now I will post the lesson for today, which is center of mass. So you have copied down the notes. So about center of mass, I mean, we've always talked about it, right? Like when we draw the force diagram, say if I want to draw the gravity working on my head, I draw an arrow, and the arrow always the tail start from the center of mass. And the center of mass normally, if the object is like the mass is evenly distributed, then it was just a regular shape. And then the center of mass will just be in the middle over here. So gravity going down, maybe the support force from my neck holding it up. So pushing force going to the left or going to the right. So that is center of mass, and center of mass is very, very important because center of mass is where we can consider the gravity is working. So even though gravity works everywhere over here, but we can consider there's a point where it's all concentrated or working, okay? And this is the point of balance. If I want to balance this pen, it's going to be somewhere over here, right? So that's the point of balance. And it's also very important. So I've written on the bottom there, say any object that's free to rotate, it will always rotate around the center of mass. So if I rotate this pen, I will need to rotate from the middle over here. Otherwise, it will just not be balanced. So if I rotate over here, it will not work. So if we think about the Earth rotates itself. It's always rotated on the center of mass. Or if I'm doing dancing, if I stand up and I do a dancing, I have to rotate along the center of my mass, which is in the middle here. I can't rotate like along my hand. If I want to rotate along my hand, I'll have to use force from the outside. So in order for me to rotate around my hand, but if I'm just free to rotate, they'll always rotate along the center mass. So I've attached a video for you guys. This video is on YouTube, so you can see how the center mass of a rotating object. So what they did was they had a bat of tennis racket. So if you throw the tennis racket will be rotating. So you don't see the pattern. But once they label the center mass, then you will be able to see at night with the visual thing they've done, and you can see how it just goes a perfect projectile motion. It doesn't matter how the bat is rotating itself, and then the center mass is just going at a projectile motion. Okay. All right. So why is center mass important? And sometimes if we have a system, and then we can use the center mass to represent the two objects. Okay. All right. So how do we find the center of mass? So we've kind of done this last year. Is basically we use the concept of torque, except now we don't need to use force. We just use the mass. Okay. So there is an equation on your booklet, or even at the end of the year for the test, they will give you a booklet that has an equation. So which goes like this, like mx equals to capital M d minus x. So that equation is very complicated. So we don't need to use that equation. I'll tell you guys a simple system. The simple system to do is just use m1 d1 multiply m2 d2. So you see the M1 is the object 1, then D1 is the object 1 to the center of mass, then M2, D2. So you times these two together, then they equal to each other. So in this way, you will be able to find out where the center of mass is, okay? So in physics, typically we just pretend it's going to be D1, D2, and then I solve the problem. And a lot of the times is when they give you D1, they don't give you D1, D2, rather they give you D1 and D2 together. They will say this, okay, so there's a ball over here, the mass is 20 kg, there's a ball over here, and the mass is 5 kg. And these two things are rotating around each other, and then say, okay, where's the center of mass? Let's say we pretend the center of mass is over here, and the total distance is 1 meter, and then we say this is D1 and this is D2, okay? So what we do is we D1 add D2 equals to that 1 meter of total distance here. And then I can solve this simultaneous equation. So m1 d1 and m2 d2, and then I'll be able to solve the question. Okay, so yeah, and then the next thing is I want to have a look of the Earth and the Moon. You know how normally we think like the Moon goes around the Earth, but that was actually incorrect. So what happens is the Moon and the Earth actually both rotate together along the center of mass. So however, the center of the mass, because Earth mass is so big, so the center of mass is much closer to the Earth. So in this case, that's actually underneath the Earth. So we can consider the Moon going around the Earth, but really the two things actually goes around the center of mass of the object. Okay, so I'll give you guys an example question as well, so you can have a look, and then hopefully you will be able to sort out these questions. Okay, all right, so for your homework, and we're just gonna do page 10, question 1, 2, 3. So and then the next lesson will be on center of mass and work using center of mass to solve conservation of momentum questions. Okay, all right, see, any question, just send me an email at vwang at apps.school.nz, and I'll see you in the next lesson.